Kotlin not to-do list, the only presentation in this conference when we will talk about things you should not do in Kotlin. This presentation is based on my book, Effective Kotlin, not yet in official publishment, still in beta version. It can be found and bought on LeanPub, but this is just a sneak peek. It will be available in like a month or two. And this book is dedicated to what should we do in Kotlin, what's good, what's nice, how we should use Kotlin features. But there are some items that are just the other way around, things you should not do, things you should avoid, things that are problematic. And this is what I collected and made a presentation, this presentation out of that. And concretely, I collected all those items into 3 big sins of Kotlin developers. And the first one is hiding too much. And I would say even more. I think it's not even that people are hiding too much. It's a growing culture of hiding things that I see in Kotlin community. And I think it's not good. Just imagine that you are in a hurry because you have an important meeting and you are looking for your car keys. But in your family, there is a growing culture of hiding things. And this is how I sometimes feel in Kotlin when I'm trying to find something, especially types, and someone decided to hide it, and I need to go somewhere, and dig to find it. So, two biggest problems biggest problem is hiding type and receiver, and let's start with something we all truly enjoy: type inference. So. We love that when we clearly see a number, we do not need to say it's a number. It's clear. The same with a string, the same with a list of numbers. But it's not always clear. Sometimes you just do not know what type is there. And when someone decided to hide it from you, you might have a trouble reading that. That's why one of my rules is specify the variable type when it's not clear. When you specify it, it's much better for a programmer, but it's also much better for a compiler. And there are 2 particular cases when it's important for compiler. To understand the first one, you need to first understand that type inference is exact. So if you set a zebra to an animal, this animal will be inferred into zebra. So you cannot set any other kind of animal. A general solution is that to set a concrete higher level type. But you not always can do that. Just take a look at this example. Imagine that you have an interface car factory when you are producing a car. But we all live in post-Soviet countries, and it's sometimes most car factories were producing the same kind of car. In Poland it was Fiat 126P. And since most of your factories produce that, you decided to make it the default. But then you decided, well, this type can be inferred because it's the same in the default car, so you can just omit that. And sometime later, someone decides that in the default car, you can omit this car as well, and congratulations. Now all your factories can produce only this particular model of Fiat. This is exactly what happened in Poland 40 years ago. And that's why my item 4 is do not expose inferred types. This is especially important information. I'm sick of finding libraries and reading their functions and not knowing what is the return type of some function and looking up and up and up to find it out. When it's an exposed interface, exposed class, some exposed function, please specify type. It's a general rule. No, not only in Kotlin. To understand another problem, think about null safety. Null safety in Kotlin is great. It protects us really well from nulls, pointer exceptions. It made nulls our friends again, but it does not always support us. It especially has problems when we are interoperating with Java. So when you are interoperating with Java and you have a nullable type, we trust that, we make it nullable. When it's annotated as not null, we trust that, we say it's not null. But what if it's not annotated at all? So we do not like this situation, and we avoid it as much as possible using variety of different annotations. Actually, when Android was changing for Kotlin, it was one of the biggest changes. It added a lot of those annotations here and there to support null safety in Kotlin. But sooner or later, you will get into a situation when you have something from Java that does not have a nullability specified. And in such a case, you have a special kind of type that is not safe. It's called platform type. Platform type can be either specified as nullable or as not null, and this is your responsibility as a developer and your decision. Namely, platform type is not safe. In those 3 lines, only user 2 will throw null pointer exception if you have a null under user. But believe me, the worst implementation is user 1, because it will also throw null pointer exception, but who knows where. When you have a platform type inferred, you can use it sometimes as a nullable and sometimes as a not nullable. So it's totally like in Java. It's totally unsafe in any place, but you are not expecting that. You will have null pointer exception, but it can blow out of any expression, and it might be hard to track down where it all started. If you set the type at the beginning and eliminate platform type, you will have null pointer exception and very direct message, where does it come from? So very easy thing to fix. So the general rule is eliminate platform types as soon as possible. Of course, it goes much further. Platform types going into our typing system in Kotlin can do a lot of harm. Just imagine that an extreme situation when you infer the platform type into an interface, type returned from a function in an interface. It means that anyone can still decide if it is nullable or not nullable. So someone in declaration side might decide it's a nullable, and on use side might decide it's not nullable. And this way you produced null in Kotlin, and you produced null pointer exception also in Kotlin, thanks to platform type, which is messing with our typing system. So eliminate platform types as soon as possible. To be totally fair with Kotlin, there is a warning in here. Listen to that. Another thing that Kotlin developers are hiding too much is a receiver. And again, it starts with a great feature. If you are setting multiple fields on an object, why referencing this object every time again and again? It's better to use apply and reference it implicitly using a receiver. But people are going too far with using receivers. And it's generally better, if it is not clear where the function comes from, it's generally better to specify receiver. And we specify it using this. So my general solution is that when you are writing extension function, instead of hiding receiver, like in here, first and drop, not sure if they are some top-level function or coming from receiver, it's better to use this. Swift often force you to do that. In Kotlin, you need to force yourself. It's even tougher when you are making receivers when you already have some receivers. So in here, you are in a class node, which is a receiver, and has a function name, property name, and you use apply after you make child, and this apply should have a child being a receiver. So in here, someone wanted to print child name after child is created. But he's wrong. As you can see, the result is created parent, not created parent.child. Why is that? To solve this mystery, you can use explicit receiver. And when you do, you are forcing your typing system to use a child receiver, and then you will see an error. Reference is nullable. That's why we couldn't get name from a child, and instead, a name from parent was used. The easy solution would be to use safe call, but the proper solution would be to not use apply in such a situation. The general rule is that when we do not really need receiver, when we are doing some additional operations, when we are doing something extra or some processing, when we do not really need this receiver, we prefer to use also or let that are not changing receiver. They are forcing us to use it using it or an argument. A special kind of that is to avoid member extensions. Because of how Kotlin is designed, it's possible to have extension functions inside classes, but it's a terrible pattern that should generally be avoided except of DSLs. And people often do that to limit element visibility. What does not work because it can still be used only in a weird way. If we want to limit elements visibility, we should use visibility modifier, for instance, private. And if you do not need class to be a member, you should extract it to be a top-level function. And this way is much better. We made our isPhoneNumber private extension function. There are many reasons why it's better. One of them is that reflection is possible. Member extensions are not even supported. The reference to member extensions is not even supported by Kotlin because it's generally something that should be avoided. There are also other reasons. For instance, when you are referencing something from the class, it's never clear where does it come from. Does this A come from A or does it come from B? Where does it come from? I actually think it's from A. When we update, when we have function that should update a receiver, which receiver should we update? It does not have any clear answer because one rabbin will say that, one rabbin will say something else. So avoid member extensions, they are confusing and they are something that we should not use. Another big sin of Kotlin developers is that we are too often choosing short over readable. And there is a common misconception that Kotlin is designed to be concise. It's not really true. When I was trying to make Game of Life in Kotlin, it took me around 10 lines in minimum using a clean code. There are languages in which it can be much shorter. For instance, in APL, 1 line is enough. So your first thought is probably, whoa, that's short. Another one is that I do not have half of those characters on my keyboard. Another such language is J. Those are champions in golf code contests, but they are not really readable languages. Those programs are not readable even for experienced APL or J developers. There are probably few of them worldwide. Is anyone using any of those? No? Okay. Kotlin is meant to be readable, and it's short only because it eliminated a lot of noise. And the difference can be well reflected on those two snippets. I asked many Kotlin developers which one do they prefer, and I was surprised how many of them actually said they would prefer the second one. Just think about it for a moment. Let's start from a perspective of a person who just came into Kotlin project. He or she do not know what is take if, let, safe call, function reference, Elvis operator. And he might spend whole day trying to figure out what is that. The first one is clear for everyone, even JavaScript developers. Even for experienced programmers, I mean, for me, I have 4 years of experience in Kotlin, and to understand this one, I need to read it carefully, like line by line. This one, I know what's that immediately. So I think the first one is much better. We all have experience in Kotlin, but we all have much more experience in general programming. Also, changing them is, when we change them, the first one is much easier. Let's say that you need to add something to branches in the first one. It's trivial, you are just adding new lines. In the second one, you need to refactor because you cannot use function reference, so you need to change it. Also, you cannot have more than 1 line on the right side on Elvis operator, so you need to wrap it somehow in some run, and you made this expression even more terrible right now and harder to understand. You can guess that debugging is also harder for the second one. The general rule is that classic and well-known structures that are designed for some tasks are easier to understand, easier to debug, easier to comprehend, and generally more readable. And finally, the last thing, who noticed what is the difference between those two? Yeah, so the difference is not easy to see it. The difference is that the first one show error when person is null or he or she is not adult. The second one shows error when person is null, he is not adult, or when show person returns null. So it might look like a rare case, but it's actually probable. And finding this bug on your code would be really, really hard. So good luck with that. General rule, we prefer classic structures that are designed for tasks we are doing. Do not introduce complexity just to introduce complexity. I think too many people are using weird structures just to use a cool and fancy structures. Of course, take, if, let, and else operator are great features, and they have their great uses. They just should be used when it makes sense to use them. There is also a thing about unit nullable, and there is a story behind it. My friend in London was asked on a recruitment process, why would one want to return unit nullable? And it turned out that the correct answer was that it behaves like Boolean, but you can use all the fancy features like else operator. So I think it's just a terrible answer, because just because you can, it doesn't mean you should. We have Boolean and all the support for Boolean to use support for Boolean instead of making some weird hacks. So a general rule is avoid returning or operating on unit nullable. I wouldn't even think someone might want to do that until I heard this story. Another story is from my workshop, where as one of the tasks, small tasks, I ask people to write factorial. This is a mathematical concept. You can make a factorial on any number. In mathematics, it's represented as an exclamation mark after a number, and someone clearly remembered about it, because when we were talking about operator overloading, he noticed that, hey, we can make a similar notation in Kotlin if we just make an extension function, an operator not. Oh, the only problem is that you could use it by not, and as you can guess, as the name suggests, this is not how you should do that. We should make it always consistent between operator and between the name. The names, in Kotlin, every operator has a very concrete name and very concrete meaning, and this is the meaning we expect from this operator. Please do not mess with that except of DSLs. So, and always every operator can be used from behind its actual name. Actually, during compilation, every operator will be compiled into this actual name. There are some cases that are not clear. Imagine that someone implemented number times function, and for one, it was clear that number times function means that we should make a function that repeats the previous one n times. But for another, it might be clear that we should repeat function 3 times. For another, it might be to produce a list of 3 functions or whatever. The point is that it's not clear at all what is the meaning of this operation. And in such cases, we should not use operators. We should prefer either infix functions like 3 times repeated, or top-level functions like repeat from the standard library. And finally, the third biggest sin of Kotlin developers, disrespecting contract. Notion of contract for me very special. I spent whole chapter about abstractions and notion of abstractions and contracts. Here, skipping to the essence, I would like to start with a rather clear item for most Java and Kotlin developers to minimize elements visibility, not necessarily for Python developers, as in effective Python there is the other way around. It's to make public, not private, against all other effective X books, which says to limit visibility. So the rule is that whenever possible, we should prefer to have more restricted visibility. And there are very good reasons for that. In general, we prefer our API to be as small as possible. API needs to be learned, it needs to be maintained, it needs to be tested, it needs to be documented. Every function that is exposed in a library or in a module is a bunch of responsibilities. It is also much easier to expose something later than to hide something. You know, if you are not sure about it, make a popular library and then start stealing things that people are using, and you can be sure they will be pretty angry. There are also a few other reasons for internal state of objects, so mainly for properties. A class cannot be responsible for its state if it does not control it, so this prev user means the previously downloaded user. But if it would be public, anyone could change it, so who can guarantee that we are consistent with the meaning? It's also easier to track how something changes, it's easier to debug it, it's easier to understand how class works when visibility is limited. But we need to understand that by limiting visibility, we are mainly specifying our expectations, but we are not really stopping people from using that. It's still formally possible. Just imagine a simple class with a private function. It's private, so you think that no one can use it. But actually one can. All that he or she needs is to sit down and reflect and reference employee, find member functions, find one by name, open it, and then you can just call it. If you think people won't do it because it's too hard, then you know nothing, Jon Snow. I can make extension function. People won't do it because we specified our expectation that we do not want them to use it. And people still sometimes do that. When you dig into some popular libraries, you will see that they often hack using reflections some classes. But they do that on their own responsibility. And if you change this class, change, for instance, the name of this function, their implementation will stop working, and it's their fault. So a contract is a kind of a communication between creator and user, and it's like warranty. As long as user is consistent with the contract, he can expect the creator that everything will work as in the contract. But when he's starting to hacking that, then it's and something stopped working, then it's a user's fault. So we specify contract by specifying visibility, and this is what stops people from using that. But we also specify contract in other ways. We mainly specify contract by documentation, sometimes too often forgotten. Documentation says what are the expectations, how function might change in the future. Think of a very simple function from standard library, list of. It has a very simple contract, very minimalistic one. It returns a new read-only list of given elements that is serializable on JVM. We also know that the result type is list, and that function is public. That's all we know. And that's a contract. It still gives us a lot of functions because list has a lot of methods, extension functions. So we can still do a lot with lists. But someone might try to hack this contract, and knowing that under the hood platform specific collections are used, he might, for instance, try to upcast it into mutable list and modify it. So this is breaking contract. So you are doing it on, on your own responsibility, and actually you should not do it. How it behaves, nothing guarantees to you. Actually on JavaScript it will work fine. On JVM it will blow an error. But who knows how it will change? Kotlin team works on immutable collections. Maybe they will be used under the hood and everything will throw an error. Or maybe it will be impossible to upcast it. I don't know. Contract is not specifying that. There is no guarantee in anything. We should instead use things that are consistent with contract. We should respect abstraction contract, and one way to do it in a respectful way is to use methods from the list interface. There are also, when you are extending some class, you should respect, when you are overwriting some function, you should respect contract of this function. And two most vivid examples are equals and hashcode. Both have a very concrete and well-defined contract. We'll not analyze it all right now. It's enough that I spent like, I don't know, 30 pages for them both on the book. But I would like to show you one example how you can break them. So let's say that you make a complex function. Who knows what is a complex function from mathematics? Complex function has a real part and an imaginary part, okay? So one might say that complex function can be equal to double when the real part is equal to this double and imaginary part is equal to 0. The only problem, what is the problem in here? Yeah, so this is not symmetric. So we can make complex equal to double, but we cannot make double equal to complex. So what we are breaking the contract, and what is the consequence of that? The consequence of that is that we cannot trust anything that uses equal under the hood. Just imagine that you have some list with a complex number, and you check if it has double 1.0. So what will be the result? Well, I don't know. It depends if collection under the hood compares this number to this number or this number to this number. So I don't know. One collection will say true, one collection will say false. And you cannot trust any of those collections. You cannot trust any contains, any set that there are no duplicates. You cannot trust asset equals. You just not know what is the result, what will be the result. And even if you check the result, you don't know if this result will be the same in a year, because someone might change something in this collection and your implementation do not work anymore. So contract, we should respect it. The same with hashcode. Hashcode has a also very clear contract. The most important rule is that hashcode should be consistent with equals. So in here, we implemented equals, but we didn't implement hashcode. It means that when you use some two objects that are equal to each other, when you have some set and you put one of those objects, you check if it contains the other one, it should return true, but it actually returns false. The reason is it requires some pages to understand it, but it uses hash table under the hood, so it looks in a different bucket than it should, so it cannot find it. So the same thing, not consistent with equals, you cannot trust map, you cannot trust set, you cannot trust anything that uses hash table under the hood. To be fair with Kotlin, there is a proper warning for that. But there is not a proper warning when you try to return constant. So this is also violating a contract of hashcode, because I mean it's not so strongly violating, because it's only said that it should possibly return different numbers for objects that are not equal. And formally, it will work fine if you return a constant number. But the problem is that you will place all elements in the same bucket, so your hash table is just useless. More practically, if you create a set from a list using the correct collection, using the correct class, equals will be used 0 times. If you use it in incorrect one, it will be used 50 million times. When you check if element is in this set, in the correct one it will be used 1 when it is, and 0 when it is not, meaning that our hash table works correctly. In the incorrect one, it's used equal is used many times. So this is the number from 1 to 10,000. We don't know. It's kind of random what number it is, and this is a number of elements plus 1 because we are checking with all the elements. So even though hash code gives us correct result, it's doing it terribly inefficiently. But also Kotlin structures has their own contracts. One of them is a property. We expect property to represent state, not to represent behavior. This is a simple example when someone used a property to implement a function to some elements. This is pretty clearly a behavior, and it should not be a property. It should be a function. We use properties to represent state, functions to represent behavior. And the other way around, if someone implements functions just to get state and to set state, now we use properties for that. And the last final thing, when you need to represent some mutable behavior or pass some behavior in Kotlin, we do not use for that interfaces like in Java. In Kotlin, we use for that function types. Function types are better supported. They are the way we generally do that, and they can be filled with much more objects. So interface only with concrete object. Function type can be filled with lambda expression, with anonymous function, with function reference, bounded function reference, or even with an object implementing function type. And that's all I had for you today. 3 big sins of Kotlin developers is trying to hide too much, choosing short over readable, and disrespecting contracts. Just for the sake of reference, here are all the items I used. Books. A book is not yet published. It's only published in beta, but it can still be found on LinPub. And this is actually the first time I say it on a conference, so it's kind of an official announcement. And slides, like always, will be published on my Twitter. And I wish you a great conference and a happy Kotlin. Thank you very much.
Does anybody have a question?
Could you get back to a slide where you showed an extension for string for checking its phone number?
Oh, okay.
It's long ago.
Yep. Oh, this is a very simple one. It should be probably more complicated.
I'm not an expert in Kotlin. I'm an iOS developer. What if I need this extension in another file? Will it be visible or not?
Well, so if you just remove this private, it will be public. So public is default in Kotlin, and yeah, those are visibility modifiers. You can also make it internal if you want it to be visible in the module, but not outside of the module.
But as I understand, it's not a good idea to make it public.
Oh, it is a good idea, but if you want to limit its visibility, you do that using visibility modifiers. Not
so
by
what's the
placing
point of making it a private extension?
So private, when you make a top level element that is private, it means that it will be visible only in the same file. So in this case, it means it will be visible only inside this class phone book. So we use that if we want to limit a visibility. So it's pretty likely that we do not want to expose this function. So if this is a general phone number function, yeah, let's make it a util and let's place it in some AXT file and make it visible for everyone. But it's not rare that we want something. We don't. I mean, we have more responsibility if you make it public. You should test it. You should make it more general. You should not make it, class specific. Okay.
Thank you.
Thank you very much. So when you talked about replacing interfaces with functional types, don't you think that it would be a fine addition to also specify a type alias to this functional type for the sake of readability? Because when you have a lot of parameters in this function, like it would be much more readable if you just name it like an interface, but actually it would be a type alias to the functional type. So like it would be, instead of date, arrow, unit, it would be like listener or something like that.
Yes, I think so. I didn't want to introduce it because it would make this slide even harder to read. Someone in here had a... Oh.
Thank you for a great presentation. I have a question about reflection in Kotlin. Do we have any way to get subclasses of parent class using reflection?
Yes. Yeah, you can do pretty everything using a reflection.
I was not able to solve that. Can you please?
Wait. So we want to make to get to the superclass.
I can easily get superclasses of the class, but I can go in vice versa way.
Well, so you want to find subclasses of a class?
Yes.
Oh yeah. So you would need to. Oh, it would be more tougher. I'm not sure at the moment how is that, but I'm pretty sure I did that one day. So you can just request for all, but you would need to use a. You can request for all classes in the project, and then you would have to filter on it, so it would be much slower and and tougher. But it's possible to load all classes in the project or a module, and then just filter out those that are subclasses of a class. But yeah, not. Yeah, in a sealed class it's easier.
Okay, thank you.
Also, enum has quite nice support that you can find. Yeah, you can find enum of some type, values of some enum. But yeah, probably annotation. No. Yeah, possible, but not really. I guess it could be. It could slow down your project if you want to do that in some part of production code. So rather think for libraries doing that during, let's say, annotation processing or something like that.
Maybe. Oh, okay.
Hello. Thanks for the talk, first of all. And the question about the slide where you are casting list to a mutable list. Can you switch to the slide, please?
This one.
If it does not work, then I believe it's not a developer's fault, because according to this COF principle, it should work. And it's fault of Java collections design itself.
Well, so as far as I remember, it's like right now, but well, it's like, okay, right now it might work someplace, but we don't know what will be tomorrow. But right now, as the last time I checked, list of returns arrays.arraylist, which supports some mutation points. So it supports set, but it does not support add. It's kind of.
This is violation of this COF substitution principle. Because if list is subtype of mutable list, then it should be replaceable with mutable list according to the scope.
Well, this is kind of a problematic thing because you're right, and this is how it should work. But Java, I mean, it's actually, yeah. So Java developers violate that because there was no interface to represent immutable list.
Yeah,
and
their fault.
Yeah, and so in Kotlin there is in Java there is only list, which translates into mutable list in Kotlin, and so immutable Java lists were just throwing unsupported operation exception for some methods. So you're right, it violates and it's a fault of actually Java creators.
Thank you.
So, I have some bugs, gifts, and I have only one. I have.
As more as you want.
All right, can you guys stay with me? Those who asked the question, and for everyone else, I think it's the end.
Yes.
So I'm leaving the stage, and thank you a lot.